Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good day. So welcome back to Hafiz channel. So today I'm going to share a little bit of knowledge because I have one of the viewer of my channel asking about what is the difference or how to fabricate a simple asymmetric supercapacitor. So basically he asking about asymmetric supercapacitor. What is asymmetric supercapacitor and what is the basic things we should know about asymmetric supercapacitor and how to fabricate it. So basically, before we go into asymmetric supercapacitor, everyone already know supercapacitor is a device that can store charge. Okay, so it can be divided into symmetric, where you have your positive and your negative is the same material. We call that symmetric supercapacitor. You can go your analysis with 3 electrode system, and also when you do 2 electrode system, you sandwich your material, you are using the same material. Okay, that is symmetric supercapacitor. For asymmetric supercapacitor, when we're talking about asymmetric, it is very essential for you to carry out your experiment from 3 electrode system, then you should follow by 2 electrode system. So it's compulsory because in 2 electrode system, hereby what is the term asymmetric comes from. You have a positive, you have a negative. The positive and negative should be a different material. Normally for positive electrode, we are using metal oxide, conducting polymer, the material that have theoretically have higher capacitance, the ability to store charge. For the what we call that for the negative electrode, basically we are dealing with carbon-based material. So means that for the carbon-based material, for example, graphene oxide, reduced graphene oxide, multi-wall carbon nanotube can be used or can be incorporated as negative electrode. When we want to fabricate asymmetric supercapacitor, we need to assemble the positive and negative. We need to sandwich together the electron in the presence of electrolyte and separator at the middle. So that's the basic thing how you can fabricate asymmetric supercapacitor. So basically people were talking about what is the difference between asymmetric supercapacitor and also supercapacitor, because theoretically it might be a little what we call that a little bit of similarity between these two, because for asymmetric supercapacitor it doesn't necessary for you to go with a positive electron. Your material should be battery type, or your material should be metal oxide, pseudocapacitive behavior, and for negative electron, it should be carbon-based material. So for asymmetric supercapacitor, it doesn't matter. For example, I take one example, simple example. For example, I have metal oxide, I combine with conducting polymer. For example, it's nickel oxide P dot. I use as positive electron. And at negative electron, it doesn't necessary you should just use graphene or graphene oxide. You can use the same material, but you add carbon-based material. For example, for negative, you are using nickel oxide, P dot, and also RgO. You introduce carbon-based element. So you just sandwich together. So these two electrodes has different material, even though the different only the addition of RgO. So that's in case of asymmetric supercapacitor. However, for supercapacitor, you should follow what we call that. You should follow for positive. It should have a battery type properties. You should have a prominent redox peak, and you should able to determine whether the material is battery type or not. Okay, that's for in term we are talking about supercapacitor. And the difference for supercapacitor, the negative electrode, it should be carbon-based material. So you can see the difference here, because even though the difference is only slightly, but you can tell if you do experiment in terms of the shape of the CV curve, the shape of GCD, all of this kind of thing, you can differentiate whether your materials belong to asymmetric supercapacitor or your material is suitable for supercapacitor. Because in the end, when we calculate it, we will calculate the specific energy and also specific power. Because the aim of supercapacitor is to produce a materials or electrode materials that capable to produce first is good specific capacitance, good specific capacity, and also they should have high specific energy and also high specific power. That's in terms of supercapacitor. That is the benchmark of the aim of supercapacitor. In terms of asymmetric supercapacitor, there is no benchmark targeted or benchmark objective KPI you should achieve for asymmetric supercapacitor. So normally for asymmetric supercapacitor, we still use the term specific capacitance instead of specific capacity. And the value of specific power and specific energy doesn't necessary to be both higher. Normally for supercapacitor, only the specific power is higher, but the specific energy is quite lower. So compared to supercapacitor that have the aim to achieve both value higher. So that's in terms of performance. So when we recap back what we learned in this video is basically talking about asymmetric supercapacitor, how you want to fabricate one. So just have a positive electrode, consists of whatever you want, metal oxide we combine with anything. So next you have your negative electrode. Negative electrode also you can use whatever you want, but the negative electrode should not be the same with the positive electrode. Then you sandwich together, then you put your separator, for example your filter paper, soak with the electrolyte. You can use liquid electrolyte and put in the middle of both electrodes. When you sandwich together and you clamp, you can measure your performance. However, there is a little bit problem in terms of stability, because when you run for stability tests, for cycling retention, for stability tests, what happens is the electrolyte might dry up. So what you need to do is you need to think how to substitute your liquid electrolyte with a polymer electrolyte or even gel electrolyte. So what you need to do is very simple that a lot of people do. You take out the polymer, for example, is polyvinyl alcohol. So you measure it and you dissolve in water until you make a solution until it is a crystal clear. Then what you need to do is you put your aqueous electrolyte. For example, is 1 molar lithium hydroxide or 1 molar KCl. Then when you mix together, you can form gel electrolyte, and this gel electrolyte, the stability retention is better compared to liquid electrolyte. So when you are dealing with the device, a lot of things will come out in the minds, a lot of problem will arise. So you need to tackle one by one. Okay. Then in terms of asymmetric supercapacitor, there is a little bit hint why actually people do asymmetric supercapacitor. So basically, when you are dealing with symmetry supercapacitor, what happened is we are talking about not specific capacitance. The specific capacitance value is quite comparable, so it's quite good. However, we are worried about stability retention of the material. So imagine when you are using metal oxide, which is nickel oxide, that have theoretically a very good specific capacity. Then you combine different metal oxide, producing bimetallic metal oxide. So even combining two pseudo-capacitive material, even theoretically you can get high specific capacitance, but you will face some problem in terms of stability. Because pseudo-capacitive, the mechanism is in terms of Faradic, we call that redox. So in terms of redox, what happened is the storing charge involves oxidation and reduction. So you will face ingression, you will face what we call that, you will face the electron will move off and move in. This process will fatigue, your material will undergo a fatigue, and a degradation is unavoidable. So in order to overcome that, researchers think about something. That's why the term asymmetric supercapacitor arises. So they need to produce something that negative electron have a material that can sustain a good stability. That's why when you try to learn about asymmetric supercapacitor, what you can do, your material, for example, I go to bimetallic oxide, nickel cobalt oxide. So in order to make the nickel cobalt oxide stable, what I need to do is I try to make the negative electron carbon-based material, for example, graphene oxide. That's why when we combine together, I can achieve certain stability, the enhancement of stability. But if you read a lot of paper, they might choose another strategy. They might put the graphene oxide inside the positive electrode, become bimetallic graphene oxide. Then in terms of that, they can also do asymmetric. The stability also can be enhanced. Okay, in terms of that, no comment. You need to do experiment, then you need to experience actually what is the benefit of symmetry and asymmetric. I think that's all, because my knowledge is not so big into this field, but I just learned it in 1 or 2 years about the supercapacitor, supercapacity. So in the next video, if you have a lot other question about how to even analyze how to fabricate a supercapacitor, supercapacitor, or even dual functional energy storage, I also will share my experience on that. Later in my video, I will share about multifunctional energy storage system that involve electrochromic supercapacitor. Electrochromic supercapacitor is an energy storage device that capable to change color upon a small potential difference. So it's quite interesting, but I need to gather more knowledge in term before talking to that video. So I think about this video, how to fabricate a simple asymmetric supercapacitor. I hope you get the point. Okay, I think that's all. Okay, bye. See you again.